we've seen different ways of representing the sample space. We've seen, up until now, we've seen tree diagrams where we start with a root and we do branching out, and that's fine when there's only 2 or 3 different possible outcomes for each, say, tossing a coin or whatever. With situations where you've got, say, rolling a die, where you've got 6 different outcomes, you can imagine if you rolled 2 dice, you would have dice 1 and you'd have 6, and then you would have another 6 off each of those. So it would be getting quite large, quite messy, and we look for a better way to come up with a way of representing the total sample space. So rolling 2 dice, we tend to use what's called a grid. And we've got die 1 and we've got die 2. Die 1 you can have, just like we had coin 1, coin 2 before with the tree diagram, we've got die 1, all the different possible outcomes, 1, 2, 3, 4, 5, 6. And with die 2 we put across here 1, 2, 3, 4, 5, 6. So we could get a 1 to 1, a 1 to 2, a 1 to 3, 1 to 4, 1 to 5, and a 1 to 6. So on, 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, 3 and a 1, 3 and a 2, 3 and a 3, 4 and a 1. If you write the what's in the column here first all the time, I think, as you go across, and then you just bring in the die 2. So this gives us the total sample space, and you can see, do a quick calculation, that there'll be 6 by 6, so there'll be 36 different outcomes. 6, 3, 6. So total number of outcomes, crosshatch number of, total number of outcomes equals 36. So if we go back to our rule of probability, the total number of outcomes is 36, so that'll be on the denominator. And that once again will allow us to answer some questions. So we've listed there are 36 different outcomes. Each of them has a probability of, they're all equally likely. So the probability of each of these cells occurring, like a 1-1, will be 1 chance in 36. Probability of a 6-3, 6 on the die 1, 3 on die 2, will be 1 chance in 36. Probability of a 6-6 is 1 chance in 36. So it allows us to answer probability questions like, what's the probability of a double? A double is where 2 numbers are the same occurring. And if you spot in the sample space here, we've got a 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So you could actually put a ring around those. And there are 1, 2, 3, 4, 5, 6. So the number of favourable outcomes is 6. Total number of outcomes is 36, and once again we always cancel down, so we've got 1 in 6. The probability of a total as in adding the 2 numbers together, greater, or total of 7, of exactly 7. Alright, so a total of 7, you have to go down to here. And then if we go up to there, total of 7, exactly 7. So it's just going to be that diagonal going bottom left to the top right. So 6 and 1, 5 and 2, 4 and 3, 3 and 4, 5 and 2. All of those will give you a total of 7. So it's also 6 chances in 36, which is 1 chance in 6. Probability of getting a 6 on 1 die only. Alright, so a 6 on one die only. So if we go down here, we've got a 6, 6, 6, 6, 6, but here we've got 2 6s, so we're only going to include 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and likewise 6, 1, 6, 2, 6, 3, up to 6, 5. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 of those over 36, and 2 will go into top and bottom, 5 over 18. Probability of a total of 10 or more. Okay, so we want a 10 or more. 6 and 2 is not going to be big enough. 6 and 3, 9, 6 and 4. So all of those will give us a total of 10 or more. A total of 10, a total of 11, a total of 12. 1, 2, 3, 4, 5, 6. So there are 6 of those, all over 36 total number of outcomes. Cancel it down as to 1 over 6. So grids are good for when there are more than maybe 2 or 3 different outcomes. Takes a little bit of getting them all down there, but once you've got them down there and you've got the total sample space, you can then go ahead and answer specific scenario type questions and work out, and it's simply counting up the number of doubles, counting up the number of ways you can get a 7, and putting it over the total number of outcomes.